Keep going.
It's already? No light blinking, but that's okay.
Okay.
Hi, welcome to my shaping room. This is Brian Hinde again. Our video number 2 in our 5 series on how boards work. We're going to talk about outline template today, and I thought I'd bring you to the shaping room to draw an outline and give you an idea what shaping rooms look like and how the outline template is brought in. You know, the outline template is, in the last 44 years I've been doing it, go up, down, backwards, and sideways. It changes, the outline template changes like the color lipstick on a woman. But in the past, probably 20 years in windsurfing, we had wide point forward, we had no nose, and now we have wide point forward again, or at dead center with full noses again. So, you know, undoubtedly all of them work. Is it just a fashion statement? Some are better than the others in some people's eyes, but you got to find out what works for you, and that's the most important thing. So, you know, we're all out there about having fun. You know, we do this to have fun, to put a smile on our face, not to get frustrated. So, let me introduce you to what we draw our outline templates with, and they're called just basically templates. I have 44 years worth of templates. I never throw them out. So once I have an outline curve, if I have to bring that curve back or look at it where I was 20 or 30 years ago or last week, if I made a new one, I have them as a reference point to bring them back. This is what is a full half a board template. You can see it. It's this piece of plywood cut out to put on both sides to draw a line. You can shift them with wider tail or wider board. They're sort of a universal object. Then when you have what's called the spin templates, one side and you flip them, then you have just the same as the other template, but they're spin templates. They do half of the board, you spin it, and you do the other half of the board. Now I'm going to use 2 templates on this person's board. He's looking for a 710, 20 and 3/8 wide with a 12-inch tail. So I'm going to first set these down for a second. You make 4 basic measurements when you draw an outline template. Is first the length of the board, obviously, which you'll be drawing. So you position this on the rocker line that you wish to draw. These rocker lines, these blanks are glued up in my rocker line, so I know exactly what I got. I'll measure a point. First measurement is 12 inches from the nose. This is a 710, so it's at 47. I'm a real advocate of keeping my wide point at dead center. That's sort of dividing the whole theory of the fashion back and forth, what is good and bad. Keeps it at a neutral point, a central point, and I've had wide points at 0 for, God, it's probably been 15 years. So last measurement I make is 12 inches from the tail. This person wants a 12-inch tail, so 12 inches from the nose, I give him a 12-inch tail. I go to the center and he wants it 20 and 3/8. Make a mark there. I'll make a reference point up here. That's kind of where my average nose has been coming out, and where I want to be, and to guarantee I'm getting what I want. So that's your nose measurement, 12 inches from the tail. Now I bring these, one is a nose template I use, out of the 2 templates I'll be using. Bring it up, put it in position, and simply draw a line. Set that to the side, and I take this. I'm going to be using this tail template. A smaller board and narrower tail. It's a high wing board for a gentleman. It's only about 135 pounds. So it needs a little more pulled in, less tail, because he has less weight. He needs less lift. If you had seen the last video, which we'll go over here in a few minutes about Bernoulli's theory of plane. And that way we'll tie this whole thing together and give you an idea of how it all comes together. Get this lined up here in the nose real quick. Basically how an outline template is drawn. Now let me back up to what we did in the first video with my prop here and sort of go through what is basically happening. Again, tail walking is no fun. You go out of control. In my belief, the wider the board, the wider the tail, the sooner the tail walk. As your board comes out of the air is trapped in here, creating a pressure zone at once you float your board. We've all experienced it. At the same time, if you need only this amount of board in the water, it's creating so much lift, you're so far back on the board, you start to lose control due to the chop, due to the angle of attack on your board. And remember, Bernoulli's principle is basically for a planing craft to come to plane is as you move forward, X amount of water is being pushed forward, just like splashing somebody with your hand. That's called your forward stream, or nowadays called a bow wave. At the same time, water comes under your board, turning your laminar flow and your wetted surface drag, and that's actually reflecting water, creating a pressure zone. But in between those two flows, water's trapped and diverted and create a static backup pressure and released out to the side, which Bernoulli clones a pressure band. Once you reach trim and plane over the top of that pressure band, you're dealing on a reflected pressure. So width is really important. Now, the width of the nose and the front. So if we're creating 85, according to Bernoulli, in the front half of the board, bringing it to plane creates 85% of the lift in this little pressure band that brings you to plane. So the wider the board, the more the pressure, because it grabs and pressures, compresses, and diverts the water more. The narrower the nose, the less the pressure. The narrower the nose, the less the drag penetrating the wind. The wider the nose, the more the bigger form of drag, because it is encapsulating more and grabbing more air. So it's going to be a thing. Is this calculable? It's probably very, very narrow, but we know for sure a no-nose with a really narrow nose, which is could be 3 to 4 inches narrower than what we're doing now, is creating a lot less lift. They shifted their wide point back. This wide point way far back with all that wetted surface does create more drag, so it probably takes a little more RPM to bring you up to plane. Everything's, you're talking about drag and efficiency, so I keep mine at center just the way I like it. Let me put some things over to the side here and we'll show you what this template looks on the outside. So, you can see that at all. It's just a simple pencil line. This is a PU urethane core. They used to be called Clark foam, and he dominated the industry. Now a company called US Blanks do. We do create full-blown epoxy and closed cell epoxy, but this is basically double stringer urethane core. It's the heaviest core that you can get. Gives you a very durable board. But start figuring out where your style is. If you really like the no-nose, then you should be always looking for that. If you're ready for a change, check out some different stuff. Everybody fits in a category. I like mine dead center. Doesn't mean you like your dead center. Me being a custom board builder will make you anything you want. But I think that one of the problems that people have is finding what they like, sticking with it, developing, growing on what they like until they finally get to the point of solidifying their style in windsurfing, because it is a lot of it fashion. Things bounce around so much. Like I tell people, I've been building sailboards for 36 years. I've been in the fashion business for 36 years. So thanks for your time again, and remember, schlag the volume, ride the width, and you'll be happier. Thanks.